Before we start today, let me tell you the difference between cooking and baking. Cooking is like replacing a HDMI port on PlayStation 4. Baking is like replacing a CPU socket on the motherboard. Cooking is more like art, baking is more like science. You can be more expressive, more artistic. In cooking, it's a very forgiving process. Baking is very unforgiving process. You need to be precise and you need to follow the recipe exactly. Otherwise, it's not going to work. That always made me wonder, how did people come up with those recipes? Do you have some of those recipes after your grandma, great grandma, like old notebooks with some old recipes? How do they come up with those recipes, right? I expect that there was a whole bunch of trial and error until something worked out and it was written down because it works. Correct proportions of stuff, correct procedure to achieve the effect that you want. Hello friends, welcome back to the bench. So I got this MSI board over here. This is the board that we removed the socket, and I turned out to have only one of these 1151 in stock. And it melted at roughly 190 degrees, something like that. It was all on video if you want to review the footage. Oh, it actually smells like burnt plastic. Oh, the socket melted. The socket has melted. So today I just wanted to replace the socket, resolder it on, and test the board. Because I have the CPU, I have everything I need to test it, and I know the board worked before, just had the bent pins or missing pins, whatever. But other than that, it booted, everything seemed to have worked. I heated it up to, I started with 190, because I figured if it's gonna start melting, I have few more, so not a big deal. But 190 didn't even melt. So I kept going up, and I went to the maximum allowed temperature by this device, which is 260. At 260, this should catch on fire. Like, well, maybe not this, but this plastic socket for the power supply, that will definitely catch on fire, and I have done that before. Which brings me to my point. By having so many failures and literally a flame touching the heater, did I damage the heater? I cleaned it a few times, and maybe the process of cleaning damaged it. Hard to say. Nevertheless, when I was when I was doing the procedure, I also used a laser thermometer. And indeed, the temperatures are a lot higher than what this shows, and I'll show you why. They fooled me. So anyways, the temperatures were high, but the solder wouldn't melt. And not only that, the socket shows no signs of melting. It looks to me like it has never been heated. And there's not a sign, and the other one melted in 190. So it's kind of tough, and you never know what kind of socket you're gonna get. That definitely sucks. But now when we set, I told you that other thermocouple that we place on the board is not really needed because the temperature is read from this device. See, there's a little hole over here to which you insert the thermocouple, right? And these two go to the 110 volts AC, and this produces 450 watts of power of heat. However, this is not populated. There's no thermal feedback from this. So when we set it to 230, God knows how it calculates that, but I'm guessing based on the power it delivers. Now it makes a lot more sense. So I was thinking of actually putting the thermocouple in there, right, and just measuring the temperature of the heater. I'm not sure, but now you can see that, I don't know if you can see that, probably not because of the light, but those wires over here, the insulation on the wires has burned. This insulation, so this is the insulation, right? And as you can see, it burned to a crisp, right? So this is the smoke that I would see occasionally. And then I lift the nozzle and the socket is not melted. Where did this smoke come out? Where did it come out from? Right? Where did it come from? And it came from here. So this is the insulation on this one. I have a replacement, a full replacement, the whole other unit. All right, a little better on the screws and stuff. Looks a lot better. This one, look at the size of the screws used here. They really didn't care. This must have been like some early prototype or something. Not sure. This one, on the other hand, uses much better screws, right? The ones that you could, I use the pliers to unscrew. Right, this is the screw, the new screw. The old screw that they used, well, on this one actually it's similar. Went crazy on the size. That's what's needed, and that's what's installed. That doesn't really mean anything, but the main issue, or the main difference, is I don't see much difference in build quality, maybe slight. It's not centered, but the size is pretty much the same, but the metal used on the new one is a lot thicker. This one is a lot thinner, so you can tell the difference in weight of it. It's slightly more stable. It's slightly heavier, obviously, and like more sturdy. This one feels a lot cheaper, like soda can. Hear the difference? But this one is 50 watts more powerful than the previous one. This is 400 watts, this is 450. So I'm gonna replace it, install it, and we'll see what the difference is gonna be. But the main issue here, the main knowledge that I've gained from disassembling this, is that there is no thermal feedback on the heater. So I gave you some bad advice, that this thermocouple doesn't really do anything. It shouldn't, but it does. But instead of being installed there, you install it on the board. Or we can still install it there, and I will give it some thought, because that gives me, because see what the issue is. I want to be able to replicate results. I'm not always going to be able to place the thermocouple in the same spot or the same way. Sometimes it's a little off, hanging off the board. Sometimes it's touching the board. Sometimes it detaches when the board is hot. And that's particularly a bad issue, because technically you should stop, cool everything down, stick it on again, and repeat. But the board is already hot, you're in the middle of the process, so now you're just unnecessarily heated up the board. So yeah, I appreciate having the sensor in the externally, where I can place it wherever I want to place it. But I would like to have the actual temperature that I put on, the actual temperature output, right, on the heater. So that's that completely changes the game. I was not using this machine correctly. That's why it was so hard. So that's the main piece of knowledge. All right, let's reinstall it and try again. So the first problem that I encountered is that the holes are in different positions. It's not a simple replacement. So first I tried removing the old plate and reusing old plate, and putting the thread on the new plate, but the holes were also in different positions, so I contemplated on drilling through it, but I finally settled on just using 2 screws, because the distance between the screws was okay, but not you can only put 2 screws in, not 4. And since it's not a mill, it doesn't have to be too stable. This works just fine. So first step is to preheat the board. I preheated to roughly 50 degrees Celsius. Since then I increased the temperature on the bed from 360 to 400. We are at 48 degrees, so let's start heating. The temperature I used, I think it was 230 degrees, 235 perhaps, which typically is way too much. You don't need that much. We see that the socket is over 200 degrees. We have 280, over 300 degrees. So you can see that the actual temperature is going to be much higher than the one shown by the thermocouple, because thermocouple is on the edge of the socket, not in the center. We had 345, 410, over 400 degrees now. And in over 400 degrees, the socket is still not melting. I would expect it to melt at 400 degrees. I ran quite a few cycles, increasing the temperature slightly and trying to observe if the socket is going to drop. It would not drop, not even in one corner. $350, 400, and still no melting of the socket or melting of the solder. I don't see much difference between this nozzle and the previous one that I replaced. It is 50 watts more powerful, but take a look at this. After all that heating, all the way to 400, over 400 degrees, the socket lifted like it's never been touched, and not a single solder ball is melted. The socket looks like new, like it has never been heated. No signs of melting, no signs of a little shininess that usually happens when the socket is slightly melted. Nothing. It's crazy, isn't it? So what's going on? Why is it not melting? Well, let's take a look at it under the scope. And as you can see, maybe let's take a look from this side first. No signs of melting, right? This might look like melting, but it isn't. It came from the factory like this. Right, not even a sign of overheating or anything, because this plastic will go a little shiny when it's heated up slightly too much. I've showed you that a few times in the past. Now the solder balls are not shiny, right? So that's a good indication that it's a lead-free solder. But lead-free solder should still melt at some point, right? Just because it's lead-free doesn't mean it's steel. And this behaves like steel almost. So let's test. I set 260 degrees on the soldering iron. So this is the highest temperature that we put on the heater. Now we just learned that this is not actually the actual temperature that we push through the board. At 230, 240, the temperature grows all the way to 400, and that is why that other socket melted in 190 degrees, because it wasn't 190 degrees. So that was the missing piece of knowledge, or my assumption actually, that was my assumption, that the thermocouple is going to be on the heater, and we have additional thermocouple that we put on the board. But nope, that was wrong. That was wrong, and I was not using the machine correctly. So now let's try to melt this ball with 260 degrees. Well, it's melting. It's melting okay. This actually, since it's 260 and it's melting very nicely, I would expect that maybe this is leaded solder, but yeah, it's melting nicely, right? Maybe not flowing because the temperature is a little low, right? Typically you wouldn't use 260 on the soldering iron, but you can see that it's melting. Now the socket is unfazed by 260. I mean, it gets a little bit shinier, and yeah, I can, if I put a little bit of pressure, then yeah, I can make some damage to the socket. But 260 is fine for this socket, right? It's not really melting. It's not releasing smoke, right? And let's try it without putting any pressure. Right, without putting any pressure, the socket is unfazed. Right, even here, right? So it's only when I put pressure I can see that it's making a dent. So what is going on here? That is weird, isn't it? Why this socket is not cooperating with us? 400 degrees. 400 degrees on the socket registered using the thermometer. Thermocouple as well. It might be off by a few degrees, fine, but you know, if this shows over 400 degrees, then say maybe it's a little over. So say there's 380 on the socket. You would expect the balls to melt, at least in some parts of the board, for the balls to just catch the board. at least in one corner, and I've had a lot of these actually, especially at first, that on one corner would not solder on, and 3 corners did, or 2 corners did and the other 2 corners didn't, or there was only one corner that actually melted and is holding onto the board, but the rest is not. I would expect that, but I would not expect the socket to just look like it has never been heated. This is what I would expect, right? Melted solder, some solder balls touching, bridges, right? Some melting of the socket. And I was thinking, that's why I replaced the nozzle, because I was thinking maybe I damaged the device, I damaged the heater, the heat is not being produced enough. But we have 2 separate devices that we're measuring the temperature, and the temperature is there. It is high temperature. So I have no idea what's going on here. I was thinking, well, I did modify the bed temperature to now produce 400 degrees instead of 360. And maybe I need to figure out better heating, because initially when I started doing this, I would put 120, 130 on the board. The board would heat up to 120, 130. But since I switched to IR heater, I figured that the board temperature is not that crucial. But in this case, it looks like I need to actually bring the bed temperature a lot higher. But why only on this socket? And why did the other socket, 1151 as well, why did it melt instantly at much lower temperature? Well, we don't know exactly what temperature was there, but the temperature, assumed temperature being set on the heater was around 190 when the socket suddenly started releasing smoke, and it melted really badly. And this one is unfazed, even if we heat it up to, even when we put 260 on the heater and heat it up to the maximum temperature that we can achieve with this device, and the socket is not melting. This would be great, right? Because there's also no deformation of the socket. That's fine. But at the same time, this plastic not melting seems to be reducing the temperature of the balls, basically absorbing the majority of that temperature coming from the top, not letting it go through the socket to the bottom. And I'm not sure what to do with that, because it's not like I can heat it even higher. I mean, I could use hot air, but how do I reproduce that process if I use hot air? It's quite a pickle. Well, in case you wondered, what's the difference between cooking and baking? Baking is a lot harder, and just like your grandmother improved the recipe that she received from her grandmother, that improved the recipe that she received from her grandmother, I need to reproduce that entire process and create the recipe that hopefully my son will improve in the future, and his son will improve it even further. That's the way it works, guys. That's the way it goes. Well, no success today, but we got a lot of knowledge, and the main piece of knowledge, as I repeated before, is that there's no thermal feedback on the heater on this device. That changes how you use that device. So disregard my previous advice regarding using this machine, and now we need to use a slightly different process to account for that. Alright, I hope you found this useful. If you did, drop a like. I appreciate that. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.